Welcome back, friends. Previously in this chapter we completed question number 1 to 10 of exercise 11.1. Question number 11 that is remaining, so we will cover it today. So what is the question number 11? Look at the following matchstick pattern of a square. The square are not separated. Okay, we already learned about the matchstick pattern for different alphabet in previous video. Okay, so here the pattern with matchstick of square is given and the squares are not separated. Two neighboring squares have a common matchstick. Observe the pattern and find the rule that gives the number of matchstick in terms of number of squares. What we need to find? We need to find the rule for number of matchstick in terms of number of square. So if for how many square, how many matchstick are required, that we need to find in terms of number of squares. Here one hint is given, so you will be understand that how can we find the pattern. So if you remove the vertical stick of the at the end, you will get the pattern for C. Now you can check your first pattern. So how many matchsticks are required for first square? We need a 4 matchsticks. For a second pattern, when two squares are in neighbor with common vertical matchsticks, you can see this is the common vertical matchstick that join both the squares. So here, how many matchsticks are required? 1, 2, 3, 4, 5, 6 and 7. So if we use this hint and if we remove this vertical sticks, so for first this pattern we need 3 matchsticks. And for second one, again we need 3 matchsticks. So here we can write 3 plus 3 plus 1 that we add at the end. Here we can write 3 plus 1. Okay. Now for next one. How many squares we have? We have 3 squares. So if we remove this vertical sticks, so for this we need 3, for this we need 3 and for last we need 3. So it means 3 plus 3 plus 3 and one vertical matchstick that we add at them. Means every time we need to add 3, 3, 3, 3 in consecutive pattern. Here again if we remove this vertical sticks, then this one is 3 matchstick, for this we need 3 matchstick, for this we need 3 matchstick and for this we need 3 matchstick. It means 4 times 3. So we can write 3 plus 3 plus 3 plus 3, but we need to add one matchstick at the end, that is 1. So now you can see this is 3 multiply 1, this is 3 multiply 2 times 3 means 3 2s are. 3 times 3 means 3 multiply 3. 4 times 3 means 3 multiply 4 plus 1. So we can use this pattern and find the rule. So let's start with the first figure. Here in this first figure, number of squares are 1. How many squares are there in one first figure? Only 1. Number of matchsticks are 4. So we can use this rule 1 multiply 3 plus 1. 1 3s are 3, 3 plus 1 4. So 4 matchsticks are there. For a second figure, we have 2 squares and for that we need 7 matchsticks. So we can write the rule 2 multiply 3 plus 1. For third figure, we have 3 squares and for that we need 10 matchsticks. So we can write 3 multiply 3 plus 1. For fourth figure, we have 4 square and number of matchsticks are 14. So 4 multiply 3 plus 1. Now you can see here only the number of squares are changing. For 1 square there is 1 in a multiplication, for 2 square there is 2 in a multiplication, for 3 square it is 3 in a multiplication. So this number is only changing. So we can use it as a variable. So that's why number of matchsticks is equal to 3n plus, so this will be rule for the square pattern. Clear? Why we add 1 at the last? Because because if we remove the vertical stick that join two square and add at the end, then we get pattern for C. This is what pattern for C, and one matchstick that we add at the end. So this way we can find the rule. Now next question is, figure gives a matchstick pattern of a triangle. Find the general rule that gives the number of matchstick in terms of number of triangles. So as we find the pattern for number of matchstick required for number of square, we can also find the pattern for this triangle. Now here you can see for first triangle we need 3 matchstick. To add consecutive triangle, how many matchsticks are required? 2. This 3 is already we have, and at the last we need to add 2 more matchsticks to have a consecutive triangle. Now for next triangle, again we need to add 2. For next pattern, again we need to add 2. Means every time we need to add 2 matchsticks. So we can find the rule. How many matchsticks are required here? 3. Now if we remove this matchstick that join two triangles, then for first triangle we needed 2, and for second we need 2. It means 2 plus 2 and 1 that we add at the last. Every time we need to add 2 times. So this one is 2. For second triangle we also need 2, and for third we also need 2. So it is 2 plus 2 plus 2 and 1 that we add at the. So here we can write 2 multiply 2 plus 1. Here we can write 2 multiply 3 plus 1. For this one we can write 2 multiply 1 plus 1. 2 ones are 2 plus 1 3. Now for this one, here we can write 2 plus 2 plus 2 plus 2 plus 1. So that is 2 multiply 4 plus 1. Clear? So if we make a table like previous one, so for the first figure, number of triangle is 1, number of matchsticks are 3, and we can find the pattern that 2 multiply 1 plus 1. What is this one? It is a matchstick that we add at the end. Now for second figure, 2 triangles are there, number of matchsticks are 5, and we can write the rule that is 2 multiply 2 plus 1. Now for third figure, we have 3 triangles and number of matchsticks are 7, and we can write rule 2 multiply 3 plus 1. For fourth figure, we have 4 triangles, and for that we need 9 matchsticks, and the pattern will be, so here it is 3 and here 4 multiply 3 plus 1. Clear? So we can find the rule. So number of matchsticks is equal to, here 3 is 2. So 2 is common, so 2 and plus 1. Again let's understand. So here we have a 3 times 2, so it is 2 multiply 3 plus 1. Why? Because we are adding 2 matchsticks every time, so 2 will be saved, and this will be the number of triangles. So we have 2 multiply n plus 1. N is what? This number that is changing. Clear? Let's take one more extra example to understand how we can find the rule for matchstick pattern. If we consider H that are joined with each other. So for one time H, how many matchsticks are required? 1, 2, 3, 4, 5. 5 matchsticks. If we add consecutive H that are joined each other. So for this, for first we need 5, and at the last we need H. We need to add 3 more matchsticks. So here 5 plus 3, 8 matchsticks. For second time, again we need to add 3. So it is 11 matchstick. 5 plus 3 plus 3, that is 11. Now for fourth one. Again we need to add 3 more, so it is 14 matchstick. Now you can see every time we need to add 3 matchstick. So here if we remove this 2, so for first we need 3 and for second we need 3, so it is 3 plus 3 and 2 matchstick that we need to add at the end, so plus 2. For this one 3, 3 and 3. So we can write 3 plus 3 and this 2 matchstick that we add at the end. For next one 3, 3, 3 and 3. So it is 3 plus 3 plus 3 plus 3 plus 2 that we add at the end. So we can write the rule here 3 multiply 1 plus 2. Here 3 multiply 2 plus 2. For this one 3 multiply 3 plus 2. And for this one it is 3 multiply 4 plus 2. So what will be pattern for this edge? It will be 3n plus 2. So pattern will be 3n plus. So this way we can find the pattern. Now let's take one more pattern. So if we consider pattern for n. So how many matchsticks are required for n? We need 3 matchsticks. So if we find the pattern for one time n, so we need 3 matchsticks. For second time, we need to add 2 more matchsticks. So here for 2 and we need 3 plus 2, that is 5 matchsticks. For third time 3, then add 2 and then add 2. So for this we need 3 plus 2 plus 2, that is 7 matchsticks. For 3 times n we need 7 matchsticks. For 4 times 1, 2, 3 and 4. For 4 times n we need 9 matchsticks. So now we can find the rule that for first we need 3 and for next we need to add 2 matchsticks with the consecutive n. So if we consider this 2 matchsticks and this 2 matchsticks and 1, that is extra. So 2 plus 2 plus 1. So here we can write 2 multiply 2 plus 1. For this one 2 and 2 and 1 that we add at the end. So 2 plus 2 plus 2 plus 1. So this can be written as 2 multiply 3 plus 1. 2 add 3 times plus 2 3. Now for this one 4 times 2 we need to add and plus 1 at the end. So 2 multiply 4 plus 1. So what will be rule for n? Here it is 2 multiply 1 plus 1. So this is 2 multiply 1, 2 multiply 2, 2 multiply 3, 2 multiply 4. So this number is changing. So that will be our variable and 2 and 1 will be constant. So here number of matchsticks will be 2n plus 1. That will be paid. So let's take one more example. So here this way you can find the rule for any pattern. If we take letter P, how many matchsticks are required for first? 1, 2, 3, 4, 5. So for one time P we need 5 matchsticks. To add second one 5 and 1 we need to next time we need to add 4 matchsticks. So here for 2 times we need 9 matchsticks. 5, 6, 7, 8, 9. For next pattern, this one is 3 times P and for this we need 9, 10, 11, 12 and 13. So we need 13 matchsticks. For next time, Again we need to add 4 matchsticks. So it is 4 times p, 15, 16, 17. So now you can directly write the rule. Therefore, every time we need to add 4 matchsticks and this one, that will be extra. So that will be 4 and plus 1. We can find the rule like table. So for first figure, we need 5. For 1 times p, we need 5 matchsticks. So that can be written as 4 multiplied 1 plus 1. Because we are adding 4 matchsticks every time, that's why 4 will be constant. So for second figure, 2 times p, and for that we need 9 matchsticks. So it is 4 multiplied 2 plus 1. For third figure, we need 3p and written is 30. So 4 multiplied 3 plus 1. For fourth figure, 4 times p, and for that we need 7 matchsticks. So 4 multiplied 4 plus 1. What is this one? The one is the extra matchstick that we add at the end. So number of matchsticks will be 4n plus. Clear? You need to find in homework, find pattern for n and so only find the pattern for that will be in homework.